question here requires us to plot a graph. It's a distance time graph, as we can see from the question here, and we are provided with grid lines and also the data to plot. So the first thing that we need to do is to label the axes, and indeed there's a prompt in the question telling us to do this. Obviously one of the axes is going to be distance, the other one is going to be time, and the convention that we use is that the independent variable goes on the x-axis, the horizontal axis. So what we need to do with this is to put in a label that says time. So we'll put that by the x-axis, the axis across there, and we also need to have a label that says distance, because that's the other axis there. So we'll put that in alongside the vertical axis, because that's where that's going to go there. Now what happens now is that we need to calibrate the axes. We need to put numbers on the axes, and obviously we're doing this that we need to be guided by the numbers that we've been provided with on the table. Well, as you can see here, that the time runs from 0 to 6, so we need to make sure that we've got a suitable scale for doing this. So obviously what happens is that 0 is going to go in over there on the left hand edge, and we've got to fit 6 seconds in, and we've got 5, 10, 15, 20 little squares, so it'll work quite well if we have 3 little squares to 1 second. So we'll make that 1, and in that case that one then be number 2, that will be 3, that will be 4, that one there will be 5, and that one there will be 6. And that's quite a good scale, because that means that we're using most of the length of the graph there. Generally speaking, the more of a graph it is that we use, then the better the graph is going to be. Now on the vertical axis, we're going to be putting values for distance. We have to go up to 45 centimeters here, and a good way of doing this is going to be for 2 little squares to be 5. Okay, so we'll make that 5. In that case that will be 10. Another 2 little squares here will be 15. That will be 20. That one there will be 25. Now this will work quite well, because the values, as you may well have noticed, are all multiples of 5. So in that case that will fit quite well on these grid lines. It means that we can use grid lines for each of the distance values. So we've got 40, and then the final one, which is going to be there, will be 45. And it's also a good idea to show the distance. Distance is measured in centimeters, so let's put that in there, and time is measured in seconds. And if we do that like that, it means that we don't need to put it in by the individual numbers. So let's now take the first of these pairs of values here, and the first of these is 0, 0. That's 0 on the distance axis, there's 0 there. So the first of the point is 0, 0. And a good way of marking a point is by using a cross, because the centre of the cross then quite clearly indicates where the position is. The next one is going to be 15 centimetres and 1 second. So that one will go in there. The next point is 25, 2. So that's 25 centimetres, 2 seconds. So that's going in there. The next one is 30, 3. So the 30 centimetres and the 3 seconds there. The next one is 35, 4. So that takes us to that point there. The next one is 40 and 5. So 40 and 5 is going in there. And then the last one is 45 and 6. So you can see then, okay, so we've then got those crosses there, and that shows the way that the points are going to be plotted on that scale there.